Here's example 2 of sketching a graph of a function f given information about f primed and f double primed. So here we're going to call the function g, but remember we've said it a bunch of times, it really doesn't matter what you call the function, all the same rules still apply. So we're going to sketch the graph of g given information about g primed and g double primed, and also some of the points on g. So g of x is a polynomial, just like in example 1, so that's good, because again, that means that the graph is going to be smooth, continuous, extend infinitely far to the left and to the right. No holes, no breaks, no jumps, no discontinuities, no asymptotes, no sharp points anywhere, just a nice smooth continuous graph. So that's really helpful for us. G of negative 3 is negative 1, g of 1 is 4, g of 3 is 2, and we're told that g primed is positive on negative 3 to 1, and 3 to positive infinity, and g primed is negative on negative infinity to negative 3 and 1 to 3. And g double primed is positive on negative infinity to 0 and 2 to infinity, and g double primed is negative on 0 to 2. Okay? And what we want to do is sketch the graph of y equals g of x. Okay? So just like in example 1, instead of jumping right into it, we're going to use these 4 steps to kind of get all our information sorted and organized. So step 1, plot the given points. Okay, so what are the given points? These 3 given points up here. Okay, so let's go ahead and make our graph down here. Let's see, yeah. Okay. X-axis. How tall do we have to go? Kind of tall. Y-axis. Okay, so what are the points? G of negative 3 is negative 1, so that means when x is negative 3, y is negative 1. Yes, let's go ahead and write it out. This is just 3 of them now and not 2. Let's write out what they are over here. So negative 3, comma, negative 1. Okay, that's one point we're going to plot. Another point is 1, comma, 4. So when x is 1, y is 4. And then the third point that we're given is 3, comma, 2. When x is 3, y is 2. Okay, 3, comma, 2. Okay, so these are the points that were given, negative 3, negative 1, 1, comma, 4, 3, comma, 2. So these 3 points here were given. So let's go ahead and plot those. So let's see, negative 1, negative 2, negative 3, and negative 1 we'll put down here about. So negative 3, negative 1 is going to be kind of sort of about here. And again, if you have some graph paper that you want to follow along with, that might be a little bit better than just trying to guess like I'm doing here. So negative 3, negative 1 is about here. 1, comma, 4 was our next one, so here's 1-ish. And then 1, 2, 3, 4. Okay. Maybe label some of these too. Okay, so 1, comma, 4 is going to be right about here, somewhere in that area. And then 3, comma, 2, so 1, 2, 3. And then 2, luckily, is already labeled. That's a little less painful. So here's 3, comma, 2. Okay. Okay. So negative 3, negative 1, 1, 4, and 3, 2. Those are the 3 points that were given. Okay, so that's it for step 1, plot the given points. Now step 2, draw a number line and label the key values. Okay. So we're going to draw a number line back up here. So let's erase these, get these out of the way. Alright, so our number line, we're going to have a lot of things to put on here, so we'll make it pretty wide. Maybe just a little bit wider, so as much room as we can. Okay, and again, we can just label it x, because we are talking about values of x, or what we're going to put on here. So label the key value. So again, what are the key values? The key values, that's just any value of x that's mentioned in the problem here. So x equals negative 3, x equals 1, x equals 3, those are all mentioned. So let's go back over here and just write those down real quick. So x equals negative 3, 1, and positive 3. Are there any other ones? So negative 3, 1, positive 3. What other values of x are mentioned? Negative 3, already have it. 1, already have it. 3, already have it. Skip infinities. Negative 3, 1, and 3, already have them. 0, there's a new one. 2, there's a new one. And there's 0 and 2 again. Okay, so 0 and 2 are the only other ones there. Okay. So your 0 and 2. Okay, so we have 5 key values, so to speak, so we want to put these on our number line. Again, we want to put them in order, so -3, 0, 1, 2, 3. So, and for the number line, it really doesn't have to be to scale. It's probably better not to, just so you can kind of space it out evenly, give yourself enough room everywhere. So let's see, -3, 0, 1, 2, 3. Okay, that is horribly, horribly not to scale, but it really doesn't matter. So now what we have here is 1, 2, 3, 4, 5, 6 separate intervals that we want to label. Just like in example 1, now we want to label what's f primed doing up here and what's f double prime doing, label that down here. So in other words, is f prime positive, is f prime negative, is f double prime positive, is f double prime negative. We're going to do that in each of these 6 intervals here. So that's going to be step 3. In each interval that we got in step 2, in each of those intervals, label f prime positive, f prime negative, etc., etc. So again, this is kind of the bulk of the work here, especially in this case because we have 6 intervals to look at now. But anyway, let's do that just like we did in example 1. So what we're going to do, well before that, to make it easier on ourselves, let's write down what are these intervals. Okay, this is -infinity to -3. Now, do we really have to do this step? No, we don't really have to, but it might help us just a little bit to be able to quickly look and see, okay, that's what these intervals are. This is -3 to 0. This interval is 0 to 1. This interval is 1 to 2. This interval is 2 to 3. And this interval is 3 to positive infinity. And again, if writing these intervals out doesn't really help you, then please by all means just skip that, don't worry about it. But now for step 3, what we want to do is go back over here and say, okay, g primed is positive from -3 to 1 and 3 to infinity. Okay, so from -3 to 1, we know g primed is positive. So from -3 to 1, okay, on this whole piece here, on both of these intervals, these 2 intervals here, from -3 to 1, okay, that includes -3 to 0 and 0 to 1, we're told that g primed is positive. So label that in each little interval here. Okay. So from -3 to 1, g primed is positive. We're given that. We're also given that g primed is positive on 3 to infinity. Okay, so 3 to infinity is just this interval here. So g primed is positive here. Okay. Okay, now we want to know where's g prime negative. Now you might be thinking, okay, we only have this, this, and this left, so naturally g prime would have to be negative on these 3. Well, in this example and in the last one we looked at, yeah, that's true. But you do want to be careful because you might have a more complicated case. Maybe g primed is equal to 0 on an interval, or you just might not have that information, in which case it'll be a little more difficult. Pretty unlikely, but it could happen. So we just do want to be careful, be thorough, make sure to read everything that we're given. So go back over here and we see, okay, g primed is negative from -infinity to -3 and from 1 to 3. So -infinity to -3, that's just this little piece here. So -infinity to -3, we're told g primed is negative. Okay. Now, we were also given g primed is negative on the interval from 1 to 3. Okay, so from 1 to 3, that's this interval here. Okay, that's these 2 little pieces here, from 1 to 2 and from 2 to 3. Okay, both of these little intervals here. Those are included in the interval from 1 to 3. So on both of these pieces, we have g primed is negative. Okay, and again, we're not really doing any work here. We're just kind of writing down the information we're given, but we're writing it in a way that's more useful to us. Okay, so we haven't really figured anything else out that's new. We're just taking the information we're given and we're writing it down in a way that's more useful to us. Like here, these points we were given, we plotted them. Okay, we didn't really do any work or calculations. We just took the points we were given, we plotted them. That's more useful to us, or it will be more useful in step 4. And here, we just took the information we're given about the first derivative, and we're writing it in a way that's more useful to us, or will be more useful in step 4 anyway. Okay, so now we're going to do the same thing with g double primed, okay, down below here. So g double primed, again, we're just going to take this information that we're given, and we're going to take it and we're going to put it over here in a way that's more useful to us. So we're told g double primed is positive from -infinity to 0 and from 2 to infinity. Okay, so g double primed is positive from -infinity all the way up to 0. So that's actually this piece and this piece, right? From negative infinity all the way up to 0, g double primed is positive. So that's both of these pieces here. So we're told, we're just directly given g double primed is positive here, and g double primed is positive here. Okay, we're just directly given that. And we're also told g double primed is positive from 2 to infinity. So where's 2 to infinity? Well, that's here from 2 all the way up to infinity. So that's these two pieces here, right? So g double primed is positive, we're given that, and g double primed is positive, given that there. Okay. And again, why do we want to label that in each interval? Why can't we just write it once? Well, we want to label in each interval because once we get to step 4, we're going to want to look at each piece at a time, okay, and use what we talked about a couple of videos ago. But we'll talk more about that in step 4, in case you haven't seen the example 1. But anyway, one more tiny thing to do for step 3. G double primed is negative on 0 to 2. Where's 0 to 2? That's this piece here, from 0 to 2. So that means G double primed is negative here, and G double primed is negative here. Okay? Alright, so that's it for step 3. In each interval, okay, so in each of these 6 intervals, we labeled where the function f, we're calling it g, but it doesn't matter what we call it, where the derivative is positive, where the derivative is negative, where the second derivative is positive and negative. Okay, now step 4 is just going to be sketch the graph, given what we did in step 3. Okay, so this is why we had to label each little individual interval separately. Okay, so even though we're told, for example, like from 0 to 2, the second derivative is negative, we want to label that in each little interval that we made on this chart so that we can look at one piece at a time and say, okay, from negative infinity to negative 3, what's going on? The first derivative is negative and the second derivative is positive. So if the first derivative is negative, what does that mean? Well, remember, first derivative, that's slope. So if the slope is negative, that means the function is decreasing. So g is decreasing and g is concave up. Okay? If g primed is negative, that means g is decreasing. If g primed is negative, that means g is decreasing. And if g double primed is positive, that means g is concave up. Okay? So decreasing function, concave up. Okay? So what does that look like? That kind of sort of looks something like this. Decreasing function, concave up. On the second interval here from negative 3 to 0, g primed is positive, that means the function g is increasing. G double primed is positive, that means the function g is concave up. So increasing function, concave up. What does that look like? Increasing function, concave up, kind of sort of looks something like this. Okay. Alright, so we can keep going on, but before we do that, let's go ahead and start drawing these pieces here. So negative infinity and negative 3, we know it kind of sort of looks something like this. Okay, it was decreasing and concave up. So what does that look like? Well, it looks like this. So let's go ahead and take this piece and put it on the graph. Now we know that when x gets to negative 3, we're at this value here. Okay, so whatever's happening, we're going to stop there. So let's go ahead and extend it out like this. Okay. Now how do we know how steep to make this? We don't, and it doesn't really matter because we're not given any information beyond what we were given to help us, figure that out. All we know is that on this piece here, from negative infinity to negative 3, the function is decreasing and it's concave up. Okay? Function is decreasing and concave up. And we also know that when x is negative 3, y is negative 1. So that's how we know to stop at this point, but we don't know how steep to make this, and it really doesn't matter. Okay? So what was next? From negative 3 to 0, what were we given? We were given all this information. We found out that the information we were given tells us that on the interval from negative 3 to 0, the graph of the function g is going to be increasing and concave up. So increasing and concave up, what does that look like? Well, increasing concave up, well, it looks like this. Let's take that and apply that to this. Now, if we look ahead a little bit, we see eventually we have to get to this point here, so let's kind of make this a little bit wider. Okay. And if you don't see that right away, then that's okay. You can just, if you need to give yourself a little more room later, you can just go ahead and erase what you have and then just do that later. We're just making rough sketches here, so it really doesn't have to be too pretty or too perfect, as you can see here. Okay, so that's from negative 3 to 0. How do we know to stop here? It looks like I kind of stopped right on 3, and the answer is we don't. We don't know what y is when x is 0, so we don't know exactly which value of y to stop on, but again, it doesn't really matter. If we weren't given that information, then all we can really do is guess and just kind of go with the flow and, see, all we can really do is just use the information we're given to make these conclusions up here, and we cannot conclude what y is when x is 0, so it just doesn't matter. Now if we were given that value, of course we'd have to use it, just like we use this value down here, but we weren't given that, so we don't have to worry about it. Okay, how about this piece from 0 to 1? G primed is positive, which means G is increasing, and G double primed is negative, which means G is concave down. So increasing function, concave down. Increasing, concave down. What does that look like? Increasing function, concave down, kind of sort of looks something like this. Okay. So let's go ahead and take this piece and put it on that interval from 0 to 1. That's going to be kind of a short piece right here. Okay, from 0 to 1, just kind of sort of something like that. Okay. And again, this is a polynomial, so you do kind of want to smoothly connect it here as best we can. And again, it's a rough sketch, so don't worry too much about it, but at least make it look sort of polynomial-ish. Just kind of smooth and connected there. Okay, so what's next? 1 to 2. From 1 to 2, what do we have? G primed is negative and G double primed is negative. So this means G is decreasing, okay, G is decreasing, and this tells us that G is concave down, okay? Decreasing function, concave down. What does that look like? Well, decreasing and concave down looks like this. Decreasing concave down looks something like that. So we want to do that from -1 to 2. Okay. Now, before we do that, you might be wondering, okay, how far can we go down this far? Should we go down that far, or do we have to stop above this? Before we do that, we have to look at the next piece really. So this is kind of where it gets a little bit tricky. We know that eventually we have to go through this point here. So before we can draw this piece here, we have to kind of look ahead and see, okay, are we going to increase back to this point, or are we going to decrease down to that point? So that's going to help us figure out, how far down is this piece going to go? Because we don't know what y is when x is 2. Okay, so this right here is when x is 2. We don't know what the value of y is because we weren't given that. So we can guess, and guessing really is the best we can do, but we can use this next piece here from 2 to 3 to kind of help us out with that. So let's go ahead and do that. G primed is negative and G double primed is positive. Okay? So this means function is decreasing and it's concave up. Decreasing function, concave up. If we're decreasing and concave up, what do we look like? Well, we kind of sort of look like that. Okay. So what does this mean? This means that from 1 to 2, the function is decreasing and concave down. And from 2 to 3, the function is decreasing and concave up. Okay. So from 1 to 2, the function decreases. From 2 to 3, the function still decreases. Okay, only the concavity changes, but this whole way the function is decreasing. Okay, so what that means is that when x moves from 1 to 3, the function decreases the whole way. So that tells us, we know then that we can't do something like this, right? Because here, now the function increases back to 3, or so back to x equals 3, where y equals 2. And we know that that's not going to happen because we're told that from 2 to 3, the function is decreasing. So that's how we know that this won't happen. Okay. So again, just kind of a little tricky thing there. You just want to watch out for that. And for problems like this, that's one of the more tricky things that could happen. So sometimes you might have to look ahead a little bit. But again, if you just keep everything organized, just work through it one piece at a time. And if you did sketch it, if you did do this without looking ahead, then if you came down here, what you would do is you'd make this next piece and you'd see, oh, okay, I have to decrease now. I'm decreasing a concave up. So you look at this and you say, oh, I made this go down too far, so let me just erase this rough sketch here and put it back up here. Okay, so again, the point is that, we're just making a rough sketch here. If you make a mistake, that's okay. Just go back, erase what you have. Look again at what you have up here, and then apply it down to here. Okay, so we'll stop around here. How do we know to stop exactly at here? Well, again, we really don't. All we know is that we have to stop above this point, because what this tells us, from 2 to 3, we're still decreasing. Okay, so we know that we just have to decrease down to this point here. That's all we know. We don't know exactly how far we're decreasing or where we're starting from, but that really doesn't matter because we're not given that. Okay, so from 2 to 3, from x equals 2 to x equals 3, we're decreasing and concave up. So that's kind of sort of something like this, just kind of sort of roughly. And again, just like in example 1, it's pretty clear to see where the first derivative changes. First derivative is negative because the function is decreasing. First derivative is positive because the function is increasing. It's pretty clear to see where those changes happen. But the changes for the second derivative, they're a little more subtle, right? Like here, Second derivative is positive because the function's concave up. And then here it really subtly kind of changes to concave down on this piece here. And then here it subtly changes back to concave up. So the changes for concavity, they're just a little more subtle, a little harder to see. And I'm rubbing off the marker here. I get better markers. Okay. So one more piece to look at, and then we're done with this example. So 3 to infinity, what's happening? G primed is positive, G double primed is positive. The function is increasing, and it's concave up. Increasing, concave up. Increasing, concave up. What does that look like? That kind of sort of looks something like this. Okay, increasing, concave up, kind of sort of something like that. So this next piece, we're just going to take that, put it over here. So from 3 to infinity, we're increasing and concave up. And how do we know how steep it is? Again, we don't, but it doesn't really matter. It's just a rough sketch. Okay. And this is our function y equals g of x. Okay. So that's it for example 2. I mean, pretty much just exactly like example 1, but a little more complicated because we have 6 intervals to look at instead of, I think it was 4 in example 1. So we have 6 intervals here, and we had that little tricky part here where, you know, we weren't sure how far down to go and we had to look ahead to the next interval. And, you know, again, it's not always obvious when you have to do that, but, you know, you could just look at one interval at a time, and if you have to go back and make a change, that's totally fine. That might happen. So anyway, that's example 2 with sketching a graph of a function given information about the derivatives.